So far in our little trip through the history of chemistry, atoms are like solid spheres. They're indestructible, the smallest thing. Okay, so a guy named J.J. Thomson made what's known as a cathode ray tube. So there's a glass tube and sucked most of the air out of it, but there's a little bit of gas in here. And there's an electrode at each end, and then you apply really high voltage across those, and you get this beam of light, or this ray. And this is a photograph of an actual one. So we see this. So that beam of particles is called a cathode ray because it always comes from the cathode and goes to the anode. Like, well, that's neat. You could make a light bulb, maybe. He did some other experiments that I'll spare you the details of. And he found that the particles of that cathode ray have these properties. They travel in straight lines. They are independent of the composition of the cathode. You can make the cathode out of different materials, and the particles behave exactly the same way. And they carry a negative electrical charge. So here's our electrical charge in a nutshell. Opposite electrical charges will attract each other. Like electrical charges will repel each other. This behavior is much like magnets, right? You have two magnets, there's a north and a south pole on each. You try to put the two south poles together, good luck, right? You switch them around, do north to south, and then they'll stick together. If you have positive and negative charges of the same magnitude, when you put them together, the thing overall has no electrical charge. So electric charge is a fundamental property of some particles. So he looked at the charge to mass ratio of the cathode ray, and he did this by applying two different fields, an electric field and a magnetic field. And one of those is going to bend this beam based on the charge of the particles, and one's going to bend the beam based on the mass of the particles. And so this allowed him to get a ratio of negative 1.6 times 10 to the 8th coulombs per gram. Coulomb is a unit of electrical charge. So that result implied that cathode ray particles were 2,000 times lighter than hydrogen, the lightest known atom. So we thought that the hydrogen atom was, like a billiard ball or something, except super tiny, right? You can't make it smaller. You can't take pieces off of it. And he's like, well, actually you can. This was big. What he had discovered was the electron. So electrons are present in all atoms. All atoms have electrons. And that's why no matter what substance he used for the cathode, he was getting a beam of electrons, and so they behave the same way. This was the first evidence that elements are formed from the same particles. Not different kinds of atoms, but those different kinds of atoms are each made up of smaller particles. Millikan did this experiment. It's called the oil drop experiment. So he's got an atomizer here, like you might use for perfume, to get a real fine mist of oil. You spray in here, and gravity pulls it down. And there's a little hole in this plate, and so some of those little oil droplets fall through. And we've got some ionizing radiation that's going to zap them and put a charge on them. We've got a light source and a microscope. And then this plate is positively charged, and that one is negatively charged. So we've given these particles a negative charge. They're going to be repelled by this and attracted to that. We also have the force of gravity pulling down on them. But we can use this electrical field to oppose gravity, and we can get them to just stay stationary. And from that information, they were able to calculate the mass and the charge of a single electron. And this is a more professional explanation. This this is the video. Come on. Eric.
In a series of experiments carried out between 1908 and 1917, R.A. Millikan succeeded in measuring the charge of the electron with great precision. In his experiment, a fine mist of oil was sprayed into the upper chamber with an atomizer. Some of the tiny oil droplets fell through the hole in the upper floor, and Millikan was able to determine the mass of an oil drop from its terminal velocity. Next, Millikan used an X-ray source to ionize gas molecules in the chamber. Electrons from this ionization process adhered to the oil droplets. The oil droplets now carry a negative charge. The negatively charged oil droplets can be halted by adjusting the voltage across the two plates. As the voltage across the plates is increased, the velocity of the oil drops slows. As the voltage is increased further, some drops will begin to move upward toward the positive plate. If the voltage is set just right, an oil drop can be suspended. When an oil drop is suspended, its weight, mass times acceleration due to gravity, is exactly counterbalanced by the electric force applied. The electric force applied equals the applied electric field, E, times the charge on the drop, Q. Since the mass of the oil drop, the acceleration due to gravity, and the applied electric field are known, Millikan could solve for Q, which is the charge on the drop. Millikan found that droplets had different charges, but each was a whole number multiple of a smaller charge, equal to negative 1.60 times 10 to the negative 19th coulombs. Millikan concluded that this was the fundamental unit of charge, the charge of an electron. From the charge of an electron and the charge-to-mass ratio of an electron determined by Thomson using a cathode ray tube, Millikan was able to calculate the mass of an electron. The mass of an electron, 9.10 times 10 to the negative 28th grams, is an exceedingly small mass.
So I'm not going to test you on this oil drop experiment either. Why did I show the video with all that physics in there? Because some of you will appreciate just the creativity in, we're trying to measure something that's too small to be seen. And this is back 1909, right? Over 100 years ago. And these scientists come up with these ideas and they work them through, and there's math involved in a lot of them. And they can figure out these things. And that's one of the exciting things about science. It's like a puzzle, right? A treasure hunt. And you have to figure out how to get there. So this was all said in the video. We end up with this idea that this is the mass of an electron and this is its charge.